Welcome back to the Deep Dive, where we take complex, essential source material and extract the crucial insights you need to be expertly informed and ready for your professional challenges.
Today, we are diving deep into what you might call the engine room of the Canadian economy, resource research and development, or R&D.
And for a country like Canada, built on such vast natural capital, minerals, energy, timber, water R&D isn't just some niche activity.
Not at all. It's the core mechanism that ensures our economic prosperity is actually balanced with genuine environmental responsibility.
So our mission today is to move past the purely technical details and really get into the professional landscape. We want to show you how geoscientists and engineers collaborate.
And why their systematic approach is so critical.
Exactly, and how their ethical duties are fundamentally defining Canada's global reputation as a leader in resource management. This is really about the standard of practice that allows innovation to serve the public trust.
We'll give you the framework for understanding the four systematic stages of these projects, where technology meets accountability, and why integration and transparency are absolutely non-negotiable professional duties.
Before we unlock that whole architecture of resource innovation, if you want to hear more deep dives that give you this kind of foundational knowledge and help you master professional responsibilities, please subscribe to hear more about the NPPE exam. Okay, so let's unpack that synergy that makes all this work. Resource R&D, at its core, is about optimizing resource use.
While ruthlessly minimizing the negative impacts, environmental and social.
Right, but that requires two pretty distinct skill sets working in lockstep: geoscience and engineering. So what's the actual, the functional division of labor between them?
Well, what's fascinating here is that the separation itself creates a necessary accountability loop. You can think of the geoscientists as the discoverers and stewards.
Discoverers and stewards, okay.
Their professional responsibility is in the fundamental science. They use field studies, remote sensing, all this advanced geological analysis to locate and evaluate resources. They provide the blueprint of what's possible and where it is.
So they're the ones saying, here's a potential resource, and here are the geological and environmental facts on the ground.
Exactly. And their stewardship mandate means they have to minimize environmental disturbance right from that initial exploration phase. They provide the scientific foundation.
So the geoscientist determines the constraints, the why and the where, and provides all that foundational data.
Precisely. And then the engineers step in as the innovators and implementers.
Okay, so they're the builders.
They're the builders.
Ah.
They take that scientific knowledge and transform it into a practical, safe, and efficient system. This means designing the actual extraction equipment, developing the processing technologies, managing waste, emissions.
The whole operational side.
The whole thing. And implementing automation and energy efficiency protocols. They manage the logistics to turn that natural potential into societal value.
It sounds like the geoscientist sets the guardrails, and the engineer has to design a system that can operate safely within them.
That's a great way to put it.
And that transformation from, a scientific discovery to a huge industrial reality, that doesn't just happen by accident. It follows a very systematic process that demands, I imagine, escalating levels of accountability at each step.
It does. Can you walk us through those four stages?
It's a process defined by a huge upfront investment in knowledge, followed by very careful risk management and continuous refinement.
Stage one is exploration and characterization.
Okay.
This is pure knowledge acquisition. Professionals are using advanced techniques. We're talking satellite imaging, aerial surveys, seismic exploration, a lot of complex lab testing, to identify deposits, quantify their scale, and characterize the quality of the resource.
Basically to see if a project is even worth considering in the first place.
Exactly. Does it make any sense to proceed?
That sets the foundation, but I feel like the next stage is where the financial pressure and the ethical challenges really start to collide.
It is. Stage two is feasibility and design.
Mm-hmm.
Once a resource is characterized, the team has to evaluate it against three big pillars. Is it technically feasible? Is it economically viable? And critically, what is the environmental impact?
And this stage must be demanding.
Incredibly, because the key professional decisions are made here that essentially lock in the project's future. They have to account for stringent safety standards, energy efficiency, all the regulatory compliance, and outline sustainable extraction strategies before any major ground is broken.
So if that feasibility study doesn't pass the environmental or safety standard, the economic argument just collapses no matter how big the deposit is.
It should. And that's where ethical commitment becomes a very practical cost calculation.
Right.
From there, we move into stage three, development and implementation. This is all about scaling up.
Taking it from paper to reality.
Exactly. Research insights get transformed into industrial reality. You're developing and rigorously testing innovative extraction and processing technologies to get ready for full operational capacity.
And then it's not over. There's a fourth stage.
Right. And this is crucial. Stage 4, monitoring and optimization. This is where that commitment to continuous improvement really shows. After implementation, professionals are constantly assessing environmental performance, productivity, community impact.
So it's about making it better over the long run.
It ensures operations run efficiently, it reduces the long-term environmental footprints, and it can even extend the life of the resource through technological refinement.
That whole systematic approach is really what underpins the immense value this sector generates. It's so easy to just focus on the technical side of things, but R&D is a massive engine for Canada.
It really is.
On the economic side, it's not just about the revenue from exports. It improves productivity, lowers operating costs, and it stimulates entire secondary industries, high-tech manufacturing, transportation, logistics.
And we're talking tangible tech advancements. Things like automated drilling systems, advanced material recovery, waste reduction methods. That's what keeps Canada competitive on a global scale.
And the social value is just as significant, isn't it? Especially when you look at remote operations.
Absolutely. Resource R&D often funds and facilitates critical infrastructure in remote and northern areas.
So we're talking better access to things like clean water or reliable energy for communities.
Yes. And crucially, it mandates meaningful economic partnerships with Indigenous peoples. This provides employment, education opportunities, and it supports community self-determination.
It's easy to focus on the big GDP numbers, but thinking about a reliable, clean water source or a new road connecting a remote community, that's the real, tangible social dividend of this work.
It absolutely is. And if we connect this to the bigger picture, the most critical element, the primary professional duty here is sustainability.
Right.
Professionals have to balance resource use with conservation. It's about ensuring current needs are met without compromising future generations. And this is where the technology applies directly to that ethical duty, especially with climate mitigation.
So when we talk about that balance, what are engineers and geoscientists actually developing to mitigate that massive environmental footprint that resource development naturally has?
Well, they're focused on technologies that dramatically reduce carbon emissions, habitat destruction, water contamination, and waste. For instance, environmental geoscientists are designing real-time monitoring systems for air, water, and soil quality.
So they can take immediate corrective action if something goes wrong?
Immediately. This commitment also drives the circular resource economy.
There's that minimum exact.
R&D is focusing on recovery methods. For example, recovering critical metals from electronic waste. That directly reduces our reliance on mining new, virgin ores.
And then, of course, there's the big one. Climate change mitigation.
The big one. Professionals are absolutely vital in developing and implementing CCUS carbon capture, storage, and utilization technologies to significantly cut industrial emissions, often by permanently sequestering CO2 deep underground.
This is where it gets really interesting for me. Where is Canada proving that this combination of R&D and professional ethics makes us a world leader? You mentioned specific innovations earlier.
Well, Canada's northern and geological complexity has really forced us to create some highly unique solutions. In mining, for instance, we are leading R&D in things like automated underground mining systems for safety and efficiency.
And tailings management, I've heard that's a big one.
It's huge. We're setting a global standard for tailings management and remediation, which is crucial given the scale of our mining operations.
And these advancements are often driven by specific collaborative hubs, right? They're not just happening in a vacuum.
That's right. Institutions like Morocco, which
Yeah.
is a university-affiliated research center focused on mining innovation, and the Canadian Mining Innovation Council, or CMIC, are driving those remote operation and safety technologies. They're making the industry safer and much more precise.
And what about in the energy sector?
In energy, Canadian R&D gave us steam-assisted gravity drainage, or SAGD. It's a critical method that's often cited for more energy-efficient bitumen recovery. And looking forward, there's major research into sustainable power, like geothermal and small modular reactors, or SMRs.
SMRs, okay, so these are the small, decentralized nuclear reactors.
Exactly. Low carbon, offering localized power solutions. They're essential for remote industrial operations and northern communities.
So it's really the complexity of the North that forces this innovation.
Absolutely. Our northern geography demands specialized R&D on things like permafrost stability for infrastructure, remote energy logistics, and protecting those extremely fragile Arctic ecosystems. This research contributes directly to responsible development in remote and indigenous regions.
Looking ahead, then, the landscape is clearly shifting. It's moving towards digital and clean technology. What innovation drivers are going to dominate the next decade?
Digital integration is paramount. We're seeing AI, advanced remote sensing, and real-time data analytics enabling more precise exploration, predictive maintenance. It's just significantly reducing operational risks.
And the focus is overwhelmingly on what people call green mining.
Completely. Clean technology and green mining. That means using renewable-powered equipment, developing water-wise extraction techniques, and moving towards non-toxic processing agents to dramatically reduce the ecological impact of our operations.
And this ties back to critical minerals, I assume.
It circles right back. The global energy transition relies on materials like lithium, cobalt, nickel for batteries. Canadian professionals are leading the R&D charge here, focusing intensely on the ethical, low-impact extraction of these resources to support global clean energy goals.
So we've covered the discovery, the implementation, the economic benefit, but ultimately all of this technical work, it's in service to the public. Let's finish by discussing the ethical imperative, the fundamental responsibilities that turn this technical work into a true public service.
This is the accountability structure that the public relies upon. Professional practice in resource R&D is really built on four non-negotiable ethical pillars. They define the standard of care.
Okay, what's the first one?
First is the absolute prioritization of public and environmental protection. Professionals have to ensure public safety and ecological preservation above everything else, actively preventing contamination, structural failure, and any unethical exploitation.
So number one is do no harm.
That's the foundation. Second is transparency and honesty. Data integrity is paramount. Engineers and geoscientists must accurately report their results, their risks, the limitations of their work. They have to maintain open communication with all stakeholders, even when the news is difficult.
And what does that mean in practice for a professional working in Canada today?
It means the third pillar is non-negotiable. Indigenous and community engagement. Ethical development requires meaningful consultation, true collaboration, and deep respect for Indigenous rights and traditional knowledge.
So it's about turning stakeholders into actual partners.
Exactly. It promotes shared decision-making and ensures benefits are distributed equitably. And finally, sustainable decision-making. Professionals are tasked with balancing economic feasibility with environmental and social responsibility.
And that must be the ultimate test of integrity.
It often is. It can mean choosing the sustainable option, even when it has a higher upfront cost. It reflects a long-term professional commitment to the land and the community.
So what does this all mean for you, the listener? Resource R&D is really the embodiment of the public trust that's placed in these professionals. Through knowledge, ethics, and innovation, they aren't just developing Canada's resources, they are positioning Canada as a definitive leader in ethical, technology-driven resource management on the world stage.
The systematic pursuit of knowledge guided by these ethical principles is how we continue to serve humanity and steward our vast natural resources responsibly.
And as we look to the future, with AI, remote sensing, and real-time data becoming so dominant in this field, here's a provocative thought to leave you with. How do professionals maintain direct accountability and integrity when exploration and operation are increasingly managed remotely by artificial intelligence and third-party data services? That is the challenge for the next generation. If you found this deep dive valuable and want to ensure you are fully prepared for your professional journey, including mastering the foundational knowledge we discussed today, subscribe now to hear more and be successful on the NPPE exam.